In this video, we are continuing on from our last class, and the last class that we had, essentially I had a bit of a power outage and we were in the middle of these slides. So the last thing we looked at was this SQL injection, and there was a video to go along with it. Okay, so you can download the slides and have a look at that video again if you want. We were just coming on to validation and sanitization as far as I recall, and that's when the power went. So validation is a process of ensuring that the data input, for example, to a form is in the right format. So this is with respect to number of characters, combination of characters, number range. So you might have a password field that says you need to have an uppercase, at least one uppercase letter and one lowercase and a number, for example. That's to do with validation. Sanitization is the process of removing illegal characters or combination of characters from a data input before possibly storing that to a database. So we have our example on Moodle, the website example with Homer, not the one with Homer, sorry, the Tutorial Republic, and in that you will see the HTML special characters function, and that removes any special characters related to that. So we'll have a look at that now in a second. So here's an example of validation using just straightforward HTML attributes. So you can have the likes of max length to make sure that it doesn't go over 10 characters. Similarly, you have minimum length, and you may have ranges. So you have a minimum and a maximum. So they're all forms of validation. You can also do JavaScript validation, where you check the format of a password, or to check to see if something is in the format of an email. Sanitization. So malicious users may attempt to put HTML and or JavaScript into an input field, which can cause problems with your website. Insufficient input sanitization can result in various kinds of code injection, including XSS is cross-site scripting. Injected JavaScript can be used to accomplish quite a lot, stealing cookie and session information, performing HTTP requests with the user session, redirecting users to hostile websites, accessing and manipulating client-side persistent storage, performing complex calculations and returning results to an attacker's server, attacking the browser, or installing malware. So you guys really need to be familiar with sanitization, I suppose, as a concept, but more so be able to identify in the code if there are techniques used that will, sanitize the input. So for example, we've seen the HTML, this one here in our code, HTML special characters. That's an example. So if you don't see this and you think it should be there, you can highlight it. Now one thing with the code is you're going to be given sample code, and you can say, put a comment to say here you need a function of some sort to eliminate special characters. Okay, now the code, as mentioned in Slack, but the code doesn't have to be functioning. Okay, you just have to kind of give a rough guideline of where certain aspects like these should be. HTML sanitization is the process of examining an HTML document and producing a new HTML. So in essence, really what it's done is looking for tags, right? So it's looking for these symbols, and what it does, say if you want to print an actual HTML string like this, right, it has tags in it, and you want to use those tags, it'll instead replace these less than and greater than that your browser would read as HTML. And if you want to print out this actual less than character, you can use these escape characters. So this ampersand LT is then less than, and GT is greater than. These here will print out a less than sign, but it won't be interpreted as HTML code. Here's another one, filter var. It's a PHP function, and it's not in the sample code, but it's just given to you as an example. You don't need to really worry about this one too much, but it's there anyway. So what this one does is, in this particular example, it checks to see if something is written in a proper format, in email format. Okay, so here filter var will check this variable email that has the 2 less than equal signs to check to see if it's in a proper email format, and it'll say that it's not because of these 2 characters. Okay, so cross-site scripting, this type of attack is based around user input to a web page. Typically it takes the form of input to message boards, posts, or comments on a page. So you have an input box, you can put in a bit of script, so you use an opening script tag and a closing script tag and then your JavaScript inside of it, and you can submit that into a database. Okay, and that's how it works. And so if someone else wants to retrieve that information, it'll retrieve that JavaScript essentially. So code is injected directly into the common post that runs on all our client machines when that post is loaded, viewed by the machine. This can be as simple as running a pop-up redirecting pages, or can try to access your system resources. There's different types of encryption, and there's encryption for your HTTP. So in other words, to make it more secure, you'd use the HTTPS protocol, right? So if you, in a practical, you might have a situation where you're asked to analyze a website, and if you know that there's no secure protocol, you can mention that. You can say this could be improved by assigning or using the secure protocol HTTPS. Okay. So data can also be encrypted to ensure that only the owner of the data can view it. This is stored data in a database, can be encrypted, and passwords should not be stored in plain text. Only a hash is stored in this so only a hash is stored this used encryption mechanism. So passwords, in the example that I've given to you with the Homer picture, the passwords that are being used are just plain text. So they're stored in a database with plain text, and when the user enters their password, it doesn't get encrypted, and it isn't checked against an encrypted format. So that is not ideal. And then so in the tutorial of the Republic, that shows how to do it properly. So how to register a user by hashing the password, and then later you can check, and when you're logging in, you check it against that hash password. And the HTTP and HTTPS, you should have probably covered some of this in your networking class. I believe this is running in parallel with my module. So the Hypertext Transfer Protocol Secure is a secure version of HTTP, and a protocol over which data is sent between your browser and the website that you are connected to. So it means all communications between your browser and the website are encrypted, and it is used in all shopping websites, banking, so anywhere where you have to use credit card numbers. If you don't have that lock symbol, that means it's not a secure website. Web browsers such as Internet Explorer, Firefox and Chrome also display a padlock icon in the address bar to visually indicate that a HTTPS connection is in effect. The major benefits of a certificate are customer information like credit card numbers is encrypted and cannot be intercepted. Visitors can verify you are a registered business and that you own the domain. Customers are more likely to trust and complete purchases from sites that use HTTPS. So nowadays, actually, if you visit a site and it's not a secure website, Chrome will show a big red error message, so enter at your own risk. Okay, so you don't necessarily need to know the benefits for your practical, but you will need to be able to identify if a site is secure or not. And so just to quickly demonstrate, so for example, if I look at the CCT website, I can see here there's a little lock, and that lock means it's a secure site. In other words, it's using the HTTPS protocol. Okay, it has got a certificate. So that is how you identify a secure site. passwords, as mentioned, they should be encrypted. So some computer systems store passwords as plain text against which to compare user logon attempts. So if you're given a login screen, you should be able to identify whether they are using hash passwords or not, or if it's just plain text. And in the registration form, you'll see the same thing. So some methods used in passwords cryptography, you do not need to know this, okay, for the practical, but just a little bit of background information. Hashing algorithms, they include MD5, SHA1, SHA2, SHA3. Salt and pepper is a technique used to add extra kind of encryption to the algorithm. Okay, so it prevents attackers from easily building a list of hash values. So that's kind of like a rainbow, or it's called a rainbow dictionary. So they could just predict what people might put in. So they put in God, they hash it, and then see what the encrypted version is. So then they can just reverse that process. And salt and pepper prevents that from happening. Okay, it's essentially an added security feature. So if we want to hash a password, the way we use the password hash function, you've got your password input right from a registration field, let's say, or registration form, and then this is just the parameter to say we are going to use the password hash default algorithm. There's another algorithm called MD5, and to do that you use the MD5 function. And then finally it's this just a mention on denial of service, and denial of service is not required for your practical. You'll see at the start of this slides that it's grayed out, but it's just I just wanted to mention on it. And essentially, in short, it is about a hacker or someone trying to attack a server by pinging that server constantly, so constantly making requests, and they can do that from 1,000 computers at the same time. And so if a server is getting a lot of requests, too many requests constantly with this for loop, let's say, it can cause order traffic to slow down, or it could actually crash the server. So that's called denial of service. Okay, so then quickly, finally, a little mention on the assignment, and I will keep this in a separate video. I think it just talks specifically about the assignment and answer your questions on that. Okay.